Okay, welcome back to our geometry videos. This is chapter 7, number 18. There's actually 4 parts to this one, each one a little bit different. Kind of using all of our geometry skills so far to try and figure out what we need to use in order to solve out for the variables here. So it says examine each geometric relationship and diagram, write and solve an equation to solve for the variable. Okay, this first one here. This looks like an angle that has been trisected. So all these tick marks here mean that all 3 of those angles are exactly the same. So this angle is the same as that angle, the same as that angle, which means m is the same as 5m minus 28. So we can set that up as an algebraic expression. M equals 5m minus 28. I'm going to add 28 to both sides, and I'm going to subtract m for both sides. So what we end up getting is 28 equals 4m. Dividing both sides by 4, we end up getting m to equal 7. In this one, we have a parallelogram. In other words, 2 sets of parallel lines that intersect, and we know from our parallel line properties that angles on the same side of the transversal are supplementary. So these two are going to add up to be 180 degrees. So 3x plus 38 plus 7x minus 8 equals 180. It's not 1,180, it should be 1. Okay. So we got 3x plus 7x, which is 10x, 38 minus 8, which is 30. So 10x plus 30 equals 180. I'm going to subtract 30 from both sides. We end up with 10x equals 150. And dividing both sides by 10, that means x equals 15. Okay, so we used the idea that these angles were trisected in order to set them equal to each other, and we use this idea that the angles are supplementary to add them up and set them equal to 180. Okay, then there's 2 other ones. Here we have an equilateral triangle. Well, I know in an equilateral triangle, all the sides are the same. AB is the same as BC is the same as AC, and in the equilateral triangle, when we draw in this altitude, this height is perpendicular, ends up being perpendicular bisector. So if this chunk is n plus 4, then this chunk is also n plus 4, which is 2n plus 8. When we put them together, that whole side. And this 2n plus 8 has to be the same as this 3n minus 1. So 2n plus 8 equals 3n minus 1. It's an equilateral triangle, so those 2 sides have to be the same. Add 1 to both sides here, and we subtract 2n from both sides there, and we end up with 9 equals 10. There we go, nice, okay. This last one here, we have a circle, so we have to know some things about a circle in order to solve out what we know here. We're told that AB equals 11x minus 1, so that's this whole diameter there is 11x minus 1. And we're told that CD, which is just this part right here, we call the radius, is 3x plus 12. So a radius is half the length of a diameter, or a diameter is twice as long as a radius, either way. So the diameter, 11x minus 1, is going to be the same as 2 of those radius. So 11x minus 1 equals 6x plus 24. And subtract 6x from both sides, and add 1 to both sides. 11 minus 6 is 5, so 5x equals 25, and dividing both sides by 5, we get x to equal 5. Okay, so for each of those we had to use kind of a unique relationship based on what we knew between the sides or the angles or whatever it was, and then set up an algebraic expression, and then of course solve that algebraic expression. If you have any questions or comments on those, feel free to leave them. Otherwise, you're more than welcome to like, subscribe, or share to our channel.